Game over. It is game over.
Game over,
cancer.
I'm Val Solomon, Director of Program Impact at Cannonball Kids Cancer Foundation.
And I'm Dana Nichols, Executive Director of CKc.
Game Over Cancer, a podcast dedicated to exploring conversations about pediatric cancer research, solutions, and inspiring family stories.
We're a nonprofit dedicated to creating innovative treatment options for kids fighting cancer and educating for change.
By creating a space for these conversations, we empower the community to take action and provide tangible hope.
Game over, cancer. Screw you, cancer. Well, today's episode is awesome as always, but it's really about collaboration. We're interviewing a young investigator that we were able to fund through collaboration with the Kindred Foundation. We've co-funded this grant. And then I think so much of the conversation talks about his consortium, which is how he collaborates globally to bring a lot of efficiency to a very, very rare cancer. And so I think it is so fun when I think we're going into a conversation about one type of collaboration and then I'm realizing it's everywhere in this field.
The whole field is all collaboration.
Yes. And that's how we're succeeding.
Yeah. And I think the big thing for me in this conversation was, we always talk about our far reaching and like the ripple effects of what you do with CKc.
Mhm.
And our guest today in our conversation, like sometimes you get your head down and you do the work, you make your gift, you do whatever, you come to the event and you're like, okay, it's in good hands.
Mhm.
And really getting a sense of how far the investment with his research has gone, I mean, truly globally for some of the hardest to treat, worst cancers you can get.
Absolutely. So we're very excited for you to take a listen today to our interview with Dr. Anirban Das.
Our guest today is a pediatric neuro-oncologist and cancer geneticist working at SickKids Hospital in Toronto, also an assistant professor at the University of Toronto. His current work is in deciphering the immunobiology of central nervous system cancers that arise from DNA replication repair deficiency. He co-leads the International Replication Repair Deficiency Consortium with Dr. Uri Tabori and consults on patients globally, including from low and low-middle income countries, to enable evidence-based care for these patients. He's a CKc Young Investigator for 2024 and a grant that was co-funded with the Kindred Foundation. Please welcome Dr. Anirban Das.
Good morning.
Thank you for being
Thanks
here.
for being here.
Good morning, and thank you, Val and Dana, for having me, and for Cannonball Kids for allowing this grant to happen and for our work to progress. Very deep pleasure to be here with you.
The honor's ours for sure. So we're excited to talk today.
Mhm.
And, we always like to just start at the beginning of how did you get into pediatric oncology?
So, as you probably know, some people have like a very directed vision of knowing what to do, but for me, it was a bit different. So, I trained back in India, that's where I am from. And there you have to do undergrads in medicine where you are exposed to all the branches of medicine, surgery, pediatrics, etc. And then fortunately, I was sort of selected to go into pediatrics in one of the most prestigious institutions known for pediatrics across South Asia. At that time, pediatrics was pediatrics for me. I didn't even know that there was a separate called pediatric oncology or like subdivisions or subspecialties like that. But fortunately, one of my mentors when I started pediatrics was trained in pediatric hematology oncology, so I got to work with him. My dissertations were with him, so that's how I was drawn. And as you know, the more you get into things, the more you kind of like them. So it was by chance, but then it was a dedicated decision to go into pediatric neuro-oncology, first oncology and then neuro-oncology when the time came.
That's fantastic. I think it makes a whole lot of sense to me that the more you like research and get to know a field, that the more deeply connected you feel to it, and the more, granular your understanding and also your inquiry goes. So tell us a little bit about your research and where all of that study has led you now.
So maybe I will also take a step back for that because it's important to understand how I got sort of drawn into what I'm doing today. So as you kindly elaborated, right now my research is focused on the germline origins of why brain tumors happen in some children and how to kind of use the body's own immune system to fight some of these rare tumors, which we now know are not so rare. So basically, it was the journey from pediatrics to pediatric oncology, and then working in one of the biggest hospitals in India, where I was kind of led into to brain tumors because nobody else was kind of interested to do that. And as you said, the more I got into and worked with patients, the more I understood the need of knowing more and understanding more to deliver the best care for my patients. So at that point of time, there were some patients with brain tumors who had some unique links related to their genetic predisposition. They had like two cancers at the same time, and we were flummoxed because we didn't know why this was happening, that a child could that it don't get one cancer on top of the other. So that allowed me to reach out to some of the experts in the field. So my mentor, Dr. Uri Tabori, I connected with him for that particular patient, and that basically began a journey of then coming to Sick Kids, getting to learn more about the disease, coming for a fellowship, doing translational research, clinician scientist training. So as you said, the more I got into the field, the more I got excited to know that there was this whole field and how you could actually understand the biology and then use the knowledge to actually treat your patients. So it started with a patient that I learned from a lot, and that actually pulled me into this field. And then I'm taking this forward now as an independent PI, thanks to grants that Cannonball and others have kind of funded me to take that journey along into treating these patients better by understanding the disease biology better.
It's incredible. I think knowing where you're saying that there's Cannonball and other funders, can you talk about the need for having foundations come in to support your work and what it means to be awarded a Young Investigator grant?
So thank you for asking that question, and that is very important for someone who is a young investigator like me, because when we start our careers, we work with mentors who are like really the leaders in the field, and we get inspired by them. But when we follow our path through independence, we are kind of still mentored, but are expected to do our own research and take our own sort of research interests forward. So at that juncture, as you know, the clinical hat that I wear treating patients is very different from the research hat that we wear. So the clinical things are kind of supported by the hospital, at least in Canada and SickKids where I work. I'm very fortunate to be in that environment that I don't have to worry about clinical issues for patients, which are very well supported by the system. The research is also well supported, but it needs funding for young people like me to start our own programs. And that's why I'm very grateful to funders like yourselves who come in this early stage of our careers to help us with the seed funding needed for us to start our own programs and our own translational research slash clinical trial programs that I'm doing with the help of this grant.
I think it's such an important piece for people to understand just how significant their gifts, if they give to CKc or other types of foundations, that really does help fill a gap that, you know, that's the problem, right? We want to be able to support the research for, you know, proven minds, proven ideas, but how do you prove yourself if you don't have any of the resources to get started? So that's where the Young Investigator grants come in.
Yeah.
And so it's almost like when we're looking for new researchers in our grant process, we get these Young Investigator applications like yours last year. And it's just so exciting because it's a new person, generally speaking, you know, in the past few years, just getting their career started, just starting on down this path. And really coming with different and amazing ideas, and also supported by amazing mentors too, which Anirban mentioned as well. And I wonder if, you know, the process, can you maybe share a little bit? You know, we're here today because you ended up with funding from Cannonball, but we're not the first grant I would imagine you have written. How many grants, how much time, how many grants do you have to write to be able to, you know, get to the point where you're actually receiving some grant money?
So many people probably do not know, or maybe some know, at least in the lay field, that in our medical training, we are not like trained to write grants in a way. So we are taught to do our research, our clinical practice, and get our dissertations through to get our degrees. But there is no formal, at least when I trained, of a formal setting to train you to how to write grants and then achieve independence. So it was a learning process for me by doing the things hands on in a way. So I was selected for a fellowship which was very clinical, but then as I got drawn into research, I had to start writing grants. And my mentors were very kind in supporting till the point that I was kind of successful in getting my own funding. So I think that is a very important component of young investigators like me, to feel supported in that initial period when you are nervous and you don't really know. So I started writing grants. I got an international scholar award that allowed me to go into the clinician scientist training program in SickKids, which has a big brain tumor research focus for children with brain tumors. So I was fortunate to start off by getting that, and then getting basically that allowed me to go into the training period and covered my training period along with my mentor's support as well. And then when I transitioned to an independent PI, I had a very clinical role at first. That was kind of the job. And the research part would only be possible with some seed funding and funders like you, foundations coming in to help young researchers like me. So again, I started writing grants, and as you write more, you kind of learn from your mistakes in a way, because you get rejections and then you get the comments and you read the reviewers' comments, and your next grant is kind of becomes better based on those comments. So that is a huge learning for young people like me to go through the process. But I do wonder that whether formal training for that, if it was incorporated earlier on in our medical training journeys, that would have helped on and like reduce the lag period from failure to success.
Yeah, it's fascinating to know that in an incredibly hard field that you already have to do years and years of education for, there's still this piece that's critical, and it's just sink or swim, like learn as you go is really hard. And I think it's always interesting to hear where there are still gaps, right? Like and that's so much of who we are, is like trying to learn about where there's a gap in this field and how do we help. And then there are all these pieces that go along the way, that it just is what makes this such a hard, overwhelming problem to solve in every sense of the word.
Yeah. And I think when I first started at CKc, probably one of the first things that, peeling back the curtains and seeing behind how things work, understanding that we had a requirement in our young investigator grants that they have strong mentors.
Right.
And to me, that made sense, because we're investing these funds and we want to make sure that, there's guidance and all of that. But in my mind, the longer we've done this, the more important I think those mentors are to even writing the grant in the beginning, right? Like, so to even be able to send something into a foundation that is competitive, you really do need that support, not just when the funds finally hit, but prior to that, just to apply and, probably even help from foundations, like the hospital foundation, if that's available, like all the support that's needed to be able to be successful. And it really is an amazing accomplishment that you've been able to, anytime someone gets funded, I'm like, yay! Right. I don't know how, but that's amazing.
I completely agree with you. So the role of mentorship and the environment that you work and training is extremely important for young investigators, and I have been fortunate to be like working with an amazing mentor and with an amazing research environment who are very supportive, and were supportive enough for me to generate some of the early preclinical data for allowing me, as you said, to write the grants for myself for taking that work forward. So I completely agree.
And also Anirban is very well known and recognized, I think, because when I don't know if you know the backstory behind your grant, Dr. Das, but when we were looking at our grant cycle last year, all the researchers and where the scores ended up and how much money we had available, CKc had about $50,000, but the grant for the young investigator is $100,000. But we so believed in the work that you were doing and how important it is for kids with central nervous system tumors that we really wanted to fund it. So we started reaching out, and we found a partner in the Kindred Foundation who, we had chats with earlier in the year and knew that we all invested in the same type of research, and they knew who you were. They knew, they were very familiar with the type of work that you do, and it became a natural fit. And I just kind of wanted to highlight that for people listening, that it's up to the researchers to do all the work and to apply for all these grants. And I think it's the onus is also on us to partner with foundations to really push that research to where it needs to be funding wise, if we can, and if it works for both missions.
Yeah, absolutely.
Thank you for sharing that. I, of course, didn't have a clue. And as you say, our goal is to work hard for our patients and try to do the best. So thank you for sharing that. And as I said, I am privileged to be like working with great mentors who guide me all the time to allow these things to sort of go forward in a systematic manner. Thank you for sharing that.
Yeah, absolutely. One of the things that's like deepened my learning or has become knowledge I've started really like piecing together as an important part of research and collaboration are consortiums. And when we came to SickKids earlier in the year and I was able to see your presentation, it really clicked for me how important consortiums are. And you are based in Canada, but you're part of a global consortium. You reach patients across the globe. So I assume there's a lot of challenges, but I think just in general, for most of our audience, I think it'd be incredible if you have a moment to talk through why a consortium is an important piece of your work.
So thank you for asking that question. And I completely agree that is one of the most important questions that we have to ask ourselves as researchers as well, because we can't work in silos. We can't work alone. We can't do anything alone. We need support. And so our consortium is focused on a so-called rare type of cancer. So we work with cancers which have DNA damage defects called DNA replication repair deficiency. And before this consortium was built, when I was training, this disorder was not even in the textbook. So it was supposed to be rare, a thing that really never sees, maybe one sees once in a lifetime. But my mentors who started building this consortium, and now I'm privileged to co-lead with them, the consortium network that we have now, physicians and scientists and patients from more than 50 countries globally. As we look deeper, as always, we were surprised to find that it's not as rare as it was supposed to be. So we have a paper earlier in this year about this high-grade gliomas in children, which unfortunately majority of them are still lethal. So there is no cure for these high-grade gliomas or glioblastoma. But if they arise from this particular mechanism, which we now going deeper learn that maybe even 10% of pediatric and young adult high-grade gliomas may arise from this mechanism. So this DNA damage repair defect can actually make these tumors sensitive to newer therapies like immunotherapies, which radiation and chemotherapy don't really work in this disease. So we learned from this global network, because it was supposed to be rare. With the one patient that I had in India and the few patients that we have in SickKids, we wouldn't have never gone to the understanding that we have today to understand that A, these are not uncommon, B, the tools that were being used to detect this were probably not good enough. So our group started developing tools that could actually enable the diagnosis. 3, working with patients and families from across the globe to understand what are the challenges. So immunotherapy is easy for us to deliver in the high income countries because we have access, but that's a big barrier in low income countries, including from my patient where my journey personally started. So it was a huge struggle. So get that advocacy on board, work with pharma partners, design clinical trials for these patients. And again, because it's supposedly rare, you can't do it in one center or two centers. You have to have a global outreach. So that's why I think it's both important to have a consortia, because we need to partner, because the patients are all across the globe for such diseases, of course, and we learn together, because unless we analyze those patient samples, which the patients kindly agreed to share with us, we wouldn't have known that these tumors are hypermutant. We wouldn't have known that they need drug A versus a combination of drug B, versus some may actually not need radiation anymore. That's a clinical trial that we are doing right now, which sounds crazy for a glioblastoma. If I was told that 5 years back that you can treat a glioblastoma without radiation, without chemotherapy, I wouldn't have even believed that. But that learning through global collaboration with physicians, families, and the patients have allowed us to reach the point that we are here today, that we are doing precision-based treatment for these tumors, which are more effective and less toxic for children and the child's developing brain.
What a wonderful example of collaboration and also like perception and ego, right? Like, because what I hear you saying, Anirban, is that when you work in a silo and you only experience as a doctor, you're only experiencing a patient with a particular kind of cancer once or twice across your career, then you do have the perception that that's rare. And then the more you work in a consortium, the more that you collaborate across the globe, you're starting to realize that, some of these repair deficiencies are actually quite more common than we thought. And you wouldn't have known that without the collaboration. And I imagine it takes a lot of work and a lot of effort to be that present across, did you say 50 countries?
Yes. So right now, and it's increasing every day, and it's amazing because we now have to do a separate tumor board for this disease entity, which is like a separate from all the other patients that we do in SickKids, because the more we kind of reach out to people and they reach out to us, we have like new patients almost every week that we need to discuss in our tumor boards and then work with the physicians, get the samples, get them analyzed and tell them which therapy may work or may not work. So it's exponentially increasing. And as I said, I started with one patient and reached out to the consortium for help. And now I see it's like much more common than what I and many others appreciated. And there is something that we can actually do for these patients. So it's very, very important. And because I come from that setup where testing was a challenge, getting drug access was a challenge, my mentors have kindly allowed me to work with many of the physicians who currently don't have access to the treatments and the tests that we have here in North America, and kind of develop a system where we are kind of able to do those tests through the research funding that you and others provide, and then feed that result back to the patient and the families and the doctors from various parts of the world to allow them to deliver the appropriate care for these patients.
It's incredible. And I think it speaks also to when we are talking to our donors, we're talking about the importance of finding the most innovative researchers, the people that are putting their life's work into very specific things, and that there's a ripple effect that comes back in quite a literal sense, that when people invest in CKc to invest in you, you're globally impacting a very specific part of the pediatric cancer world. And I think that's gives me a lot of hope that, we say why people should work together. And I think everyone knows that. But then like putting pencil to paper, that's a lot of work for a field where you already said there's a whole nother thing where you have to do grants and do all of these pieces. But that really has such an incredible return. It's really interesting to think about. I also think it speaks to this idea of research is what we know now. Something is, until we've all communicated or until you've come together as a consortium, it's much rarer than we know, because that's where the research stands today. And that's what's fascinating about this field for me is, as you say, like 5 years ago, if someone told me this, I wouldn't have believed them. It's incredible to think about what perhaps comes down the road in another 5-10 years.
Exactly, and you hit the nail, because though we suppose that this was a rare thing and we knew from previous trials that immunotherapy, at least in the form that was there at that point of time, didn't really work, the tumors that I kind of work with are kind of unique because they have so much genomic instability. They change their minds all the time. And I don't want to go into too much of the science talk, but what I want to emphasize is that because these tumors change their mind as we treat them, we learn from the tumors. So that allows actually that knowledge to be translated into other kinds of tumors. And we are seeing more and more that what we are learning from what we thought as a rare tumor subset not only impacts when you bring people together, many people around the globe, but also expands that learning and allows some knowledge from that learning to go into other tumors that we and others treat. So it's very intriguing for me and intellectually satisfying, because we are able to do something for the patients that we have at hand, but also have this learning process going on with collaborators learning together to actually have that impact much wider for other tumor types that may benefit for similar kind of approaches.
Yeah.
Wow. Yeah, it's so valuable. And the other thing that's occurring to me as we're chatting about this is, when CKc was formed, it was important for our founders and for the mission that we invest in research that was innovative, And so that's a huge part of what we do. But also there was a stress on that it's also accessible. And I think accessibility maybe 10 years ago when we were thinking about it was maybe a concept of if you are in Orlando where we're based and the only person that offers a treatment is based in California, you need to go to California and all of the challenges that comes with that for a family. And so how do we get as many innovative treatment options available, but in a way that they're accessible? And I think this is a really great explanation or example of a different kind of accessibility. And sometimes that is not that the family can travel there to the treatment. Sometimes that is doctors sharing information, and now and you being able to run tests and then feed the information back to the hospital where the child is being treated, and that happening on a global. I mean, I think we had this idea like, yeah, you shouldn't have to drive or fly somewhere, but the idea that this is translating across time zones across the globe is so. I mean, it's so meaningful, I think, for the work that we do.
No, thank you for highlighting that. And I just want to add that it's actually, as you do more and you learn more, I was brought up on the philosophy that, as you said, the patient should not need to travel. It should be the samples that travel to allow the patients to stay near to their home for the treatments to kind of happen and materialize. And as you said, the access is actually two ways. On one foot, we have to get the access for the drugs that are available today to the patients across the globe. And it's also for the newer agents that are coming up. That's why we have made a conscious choice of doing the future trials again under consortia, not our consortia, which is mainly research, but other consortia that we work with. As you know, there are clinical trial consortia, because the end game is to translate these and have the next generation of therapies come in. And we are also kind of working, or are fortunate to work with groups that are not saying that you have to limit your clinical trials to North America or Europe. So the clinical trials that we are kind of designing right now are not only in North America and Europe, and we have to choose some specialized centers in US, for example, because these are complex disorders that do need some amount of expertise. But the approach, as you said, is global, because we want to have the low middle income countries also join us, people from the southern hemisphere also join us. So that's how one approach is for the clinical care that is there and there today to help that happen, and for the next generation of clinical trials to make sure they're as wide as we can practically do, and make sure that it reaches the widest number of people and allow them to get access to the next generation of therapies.
Yeah, I think when you talk in that manner, it makes me feel hopeful, and that pings for me. What makes you feel hopeful in this field, or what makes you excited in this very, very long game you've invested in?
So what keeps me excited is the impact that we see in the lives of our patients every day. So one of the most satisfying roles that I am fortunate to play is that to get the clinical information, think about the patient, discuss with our team of experts that we are lucky to have in the consortium, analyze their tissues, put that data in the clinical context, and then feedback that information to the physician who is treating the patient to see that treatment A may not work, treatment B may work, and that needs to be a combination of drug A and B and C, for example. So that is like a real-time kind of satisfaction that you are able to help patients who basically had a death sentence, because once you hear glioblastoma, you know there is no cure. But for this particular subset, we have now patients who are surviving for 7-8 years. They have their issues because they do have brain tumors and they are not like normal kids. But more and more, we see at least a subset of patients with this disorder going back to school, leading their normal lives, being on treatment, mind you, for prolonged periods of time, with some now actually coming off treatment and being, I'm still afraid to call them cured, but we are hopeful that we are reaching that for at least some patients. So that is a very satisfying part of my day-to-day job to see that. The other part is the research component of, as we go deeper, we learn of how difficult those tumors are, but how if you can put effort and you, because you don't know anything, you ask people around of how to kind of know more and dive in more depth about the questions that you're not able to solve today, and then you get surprising findings to say that, okay, this is something that I didn't even think of this tumor could do when it kind of recurred after the first treatment. And now that is not only the science, but that information allows you to get the next drug to the patient and keep on helping them over time. So both ways, the research part and the clinical or the relatively immediate clinical translational application of that keeps me hungry for doing this more and more.
Well, I'm grateful there's something to keep you hungry
I
because
know.
this is much needed work. It is our honor to talk to you today. And I thank you for taking time for us because I think you have so much knowledge and are such a shining example of why we're here and why we're doing the work we're doing. So I really appreciate you. Dr. Das is the reason CKc exists and why we are working to raise money to fund innovative research like his. So for all of our listeners, if they want to make a gift, if they want to learn more about research, you can head to cannonballkidscancer.org. And we have stories about the work Dr. Das does, as well as how they can get involved.
Exactly. And we want to thank you for listening to Game Over Cancer. Did you know that leaving a review will help us reach more listeners? So go ahead and do that. Try to do 4 or 5 stars, please.
Leave a review it's nice.
But only if it's good. This is a great conversation. I'm really happy that we were able to bring Dr. Das to our listeners.
Yes. Thank you so much. It's our pleasure to have you. We appreciate your time.
Thank you so much for having me.
Yeah, absolutely. Until next time, thank you for tuning in. We appreciate everyone's commitment to be part of our fight. I'm Dana Nichols.
I'm Val Solomon.
And we will see you later.
Join us as we transform fear into courage and turn adversity into opportunities for change.
If you want to be involved in the conversations that create change in the world of pediatric cancer, take a moment, share, like, and subscribe.